Hi everyone, we are all back and it's time to look at image displacements. So here I've got a large file or data set of images. So I could take these images, again, treat them as such, and these are of our kind of magnetic particles. Again, as you can see, when you're working with images, especially these large data sets of images, it's going to take some time essentially to download them, and because we're basically storing each of these images available for our basically for our manipulation a little bit later on. So we can actually track and look at image displacements. So for example, I could compare an image with image displacements two images. So 1 and 8, for example. I'm doing it 1 and 8 because I want to get basically, we're going to roll these particles after 5 seconds. Each of those images corresponds to 1 second. So I want to look at a stark contrast and we can actually see the difference. And you can actually visualize the displacement. So you can see here, look, the particles have moved from one space to another. So you're looking at kind of the movement and the motion of those particles. If I instead did images 1 and 2, for example, if there's no change, you'll basically just see a lot of black. So let's wait. Oops. But we get a little bit of, strange things here. There's a little kind of scaling there. So you can go ahead and see 1 to 10. So we can look at that. And you can start to visualize and look at the displacement between images. So this automatically kind of tracks it and takes a peek at what you're, again, it scales and you actually see kind of the large degree of motion there. So that's when the particles are moving. So for example, image 1 versus image 10, if we flip back and forth, you see particles move. 1, 10. So that's essentially visualizing that type of motion. You can also track certain features in images. So if I want to look at image, if I want to track between image 1 and 6, it can automatically track for me what Mathematica thinks are the key features in that image. So if I want to try to do some automatic tracking here, I can see and I can show you the points that will be being tracked. So pretty good here. When you look at the original images, so images 1. So let's show this, and let's do, for example, let's show here and here. Let's see if we can, I'll blow this image up so we can kind of zoom in and see it. So pretty good here. It's tracking all those particles, but we have some kind of junk in here. So we have to kind of be considerate of what's going on there. So we need to kind of understand, and then, and then we can kind of start to get into it. But you see here it's tracking, for example, this component and all those other things. So we can actually also see what's left at basically the point 2. So initially, again, it's identifying those features, but once we look at point 6, for example, we started to lose some of our particles. So we lost essentially the tracking here. So pretty good tracking. Again, very, very good for kind of a first shot and an automatic feature detection. If we clean up our images, we could probably even get better. So for example, I can now actually tell what to track. So here, I'm looking at component measurements, and I am basically measuring the centroid of each of the particles. So I'm telling it what features to track. So I am going to look at image feature track between these two images of these tracking features. And when I do that, I get a nice, I remove those kind of nasty features there, so I'm focusing in on it. And then at the end, I get a little bit something like this. So you may be asking, why didn't it track it? What's going on here? Well, again, they're moving quite a large distance between image 1 and image 6. So it can lose the feature depending on how far away it is. So you will work in your problem set on how to develop basically a program in order to track all those particles, maybe looking at nearest. But anyways, that'll be fun later. Next time we're going to do some computer vision, and with that, we'll be done with lecture 4, and then on to mechanics. So I'll see you all next time. Thanks. Bye.